All right, guys, are there any questions over any of the assignments so far? Any questions over any of the homework assignments thus far? Questions on any of the homework assignments? Okay. So, what we're looking at today, so you need a note sheet. Everybody has a note sheet, yes? A triangle is isosceles when it has at least two congruent sides. When an isosceles triangle has exactly two congruent sides, the two sides are called the legs. So, the two congruent sides are called the legs. The angles formed by the legs is the vertex angle. So the angle that's formed by the two congruent sides is called the vertex angle. The two congruent sides are called the legs. Now the third side is called the base. And the two angles that are next to the base or a part of the base are called the base angles. And the base angles are actually going to be congruent. Base angle theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. So if two sides of a triangle are congruent, the angles opposite them are going to be congruent as well. So here, angles B and C are going to be congruent because they're opposite the congruent sides. The converse is also true. If two angles in a triangle are congruent, then the sides opposite those angles are going to be congruent as well. Questions on this here? So if we look at this here, in triangle DEF, DE is congruent to DF, and they have that labeled. Name two congruent angles. Angle F would be congruent to what? Because the angles opposite congruent sides are congruent. Because it wants two congruent angles. So FD and ED are congruent because they told us that, but they wanted two congruent angles. And the angles opposite congruent sides are congruent. Now this time we're told that angle A is congruent to angle B. Name two congruent sides. Well, the side opposite angle A is BC, and it's going to be congruent to AC, the side opposite angle B. Yes. Questions on this here? Complete the statement. If HG is congruent to HK, so HG is congruent to HK, then angle what is congruent to angle what? So the side angle opposite HK is G. And we can just call it angle G. Now the angle opposite HG is, but how many angles are at point K? Two. We have two because we have this angle and we have Since we have two angles, we have to use 3 letters. HKG or.
Wait, why is it J involved in it?
Because we're just talking about this angle here. Because this is the only angle we want. So HKG, because that angle is congruent to angle G. HKJ, we don't know if it is. It could be, but we don't know. Questions on this here? And GKH. So you just need one of those two. You don't need both. Any questions on this here? Let's look at the next one. Complete and copy the statement. If angle KHJ, this angle here is congruent to KJH. So these two here. Then what? So the sides opposite these angles would be congruent. So one of the sides would be what? JK. And the other indeed would be HK. Because the sides opposite congruent angles are congruent.
Oh.
Questions on this here? So, this angle is opposite the side HJ, yes? And this angle is opposite JK, yes? So one's opposite HK, the other is opposite KJ. Sides opposite congruent angles are congruent. So those two sides would be congruent. Corollary to the base angle theorem. If a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then it's equilateral. Because we said the sides opposite congruent angles are congruent, yes? So these two sides are congruent, which means these two angles are congruent, which means this one has to be also. So if it's equilateral, it's equiangular. And if it's equiangular, it has to be equilateral. So if we have one, we have to have the other. So here, they gave us this triangle and told us that all 3 sides are the same, yes? So that means it's equilateral, which also means it is equiangular. So all 3 angles have to be the same. Yes, and it just happened to work out that that's actually lined up quite well. Now, the 3 angles are x, x, and these add up to be? Because the sum of the interior angles of a triangle are always 180. Triangle sum theorem.
Is that before?
4-1, yeah.
Okay, I haven't.
You're good. The interior angles of any triangle is 180. So x plus x plus x is? Divide both sides by 3, and x is equal to? That's it. Questions on this here? Which actually means any equilateral and equiangular triangle, the measures of the angle should be 60 every time. So, questions on? Yep. Find the length of ST. Well, what do we know about the three angles?
They all equal 5.
Well, all the three angles are congruent, yes?
Yes,
So it's equiangular, so it means it's equilateral, which means SU is and ST is, because all three sides are the same. So ST is 5.
just straight to the point. I was like 5.
5, it's just 5. Questions on this here? Yes.
Why didn't you put the line over ST?
Because we're talking about the measure of ST, not its line segment.
The line itself.
Its length. Good question.
So why are those 5s? Why are those 5?
Because if it's equiangular, it has to be.
Oh, okay.
If a triangle is equilateral, then it's equiangular.
I'm sorry, I didn't see that 5 on the other side. I
Yep.
line.
Yes. So we want to find the value of 2x. Yeah, most of them are. Now, they told us one of the angles is 2x, and they also told us that it's, so it's all are 2.
So 2x plus 2x plus 2x. Whoa.
Because since it's equilateral, it has to be equiangular, so they're all the same. So if we add these all up, 2x plus 2x plus 2x is 6x. Divide by 6, x is. What did we say the equiangular, all the angles are going to be? 60 on the previous one, yes?
Does that say 30 or 8?
X is. Questions on this here?
Wait. Sorry.
Questions? Because what did we find each angle before when they didn't give us 2x, they only gave us x? We found the values were all 60, yes?
Okay.
So each angle in an equilateral triangle is?
Oh, so you were showing that also.
Find the value of x and y. So we look at this here. So we're going to use these properties. Now with the first triangle here, this one here, all three angles are the same. So it's equiangular, which means it's also equilateral. So these three sides are the same. And when I work at these here, yes, so I go on and draw those in, the congruency marks. Now on the other triangle, we have two congruent angles, and the sides opposite congruent angles are congruent, which means this would also have one mark. Because this one has one, so that one will have one. Because they are the same. So y is what? And this here would also be 4. So x plus. Bless you.
Did you almost trip? Or you're like walking?
No, the soles on these shoes are coming apart. Yeah, the heel is coming. Any other questions on this here? Let's look at this next one. Now again, they gave us one of the triangles is equiangular. So it also means that it is. So that means all three of these sides are. So this is 28, and 4y would be equal to.
Oh, we gotta solve that. Oh, just like
So then we can.
divide. Got that third grade mind in my brain still. Mrs. Kate's teaching.
So it also is telling us that these two sides are congruent because they're both 28, yes? Not quite. Yep, 2x is an angle, and we also have our degree marker. But the sides opposite the congruent, the angles opposite the congruent sides are congruent. So both of these would be 2x. Because the sum of the interior angles of a triangle is 180, yes. But how many angles do we have in a triangle? So we have 2x and 2x. Do we have the third angle? However, what do we know about the angles for this triangle here? They're all 60, because we already found that earlier. So these are all 60, yes? And because two angles that make a straight line add up to be 180, yes? So we could put, so we add like terms, yes? So 2x plus 2x is, plus 120 is, now what? Yes. Any questions on this so far? So we divide both sides by 4. And x is? So what's half of 60? What's half of 30? Because a fourth is half of a half. Because questions on this here? Now, yeah, so let's look back at this for 1 second. So we did find, sorry, is this? So we do know that that angle is 60, yes? One of the formulas we had the other day, the exterior angle is equal to what? The sum of the opposite two interior angles. So we could have said 2x plus 2x is equal to 2x plus 2x is same exact thing. Because how did we get 120? We subtracted 60 from 180. Both of them work. Any other questions on any of this here? This here is the last one, yes? Now, if we look at this here, so for this triangle here, all three sides are congruent, yes? Which means all three angles are congruent. So x is all three of these angles are the same, yes? So this is 90, yes?
Can't you just like subtract 90 from 90 to get the other side?
That would get you your two sides, and you'd have to add those two sides together.
So any questions on what we've done so far? Because we just did a whole lot all at the same time. So the first triangle, the one with x, all three sides are congruent, yes? So all three angles must be 60. They all are the same. Now they told us this whole angle is 90. Part of the angle is 60. So 90 minus 60 gives us 30. So this angle right here is, okay. Now in the other triangle, we're told that these two sides are congruent. So the angles opposite those two congruent sides are congruent, yes? So this angle up here is plus y is,
So 60, like,
and x is. Questions on this here?
so
60. Since it's an equilateral triangle, it's also equiangular. You're welcome. I gave y'all 6. 1 for Grace.